View of trig, it reminds us of what our ratios are. Sine, cosine, and tangent. You guys remember we had that word SOHCAHTOA to help us remember our ratios in geometry. And the SOH in that word, SOH, went with this part. S was sine equals opposite over hypotenuse. That was your O and H, right? Then the next part of that was CAH. The C stood for cosine, is equal to A over H, adjacent over hypotenuse. And then the TOA, the T stood for tangent, is equal to opposite over adjacent. All right? And we said that this is what we could use to find missing sides specifically in right triangles. So they're going to have a 90-degree angle in the corner there if we are going to use trig to solve for any missing sides or missing angles. It says to find a missing side, you would set it up just like this, okay? And your missing side is either the opposite or the adjacent or the hypotenuse, or the opposite or the hypotenuse, right? So you'll have a variable in one of those spots because it's an unknown. While your angle, your theta, should be known if you're looking for a missing side. However, let's say I know all the sides, but I don't know the angle. I can also use trig to solve for a missing angle. Okay, but it'll be a little bit different because I can't just multiply to get rid of the fraction like I could if this was one of my variables, right? Here, this is going to be the variable. So I would need to get rid of tangent in front of it, or cosine in front of it, or sine in front of it if I'm trying to solve for it, right? And they remind us over here in this column that in order to find a missing angle, to get rid of tangent, cosine, or sine, you take the inverse of that function, okay? So that's what these are. Sine inverse of your ratio, cosine's inverse of your ratio, or tangent's inverse of your ratio. All right? So let's look at some actual problems and see how we could solve for some missing pieces. So it says in this first 4 questions, you're going to find all the missing sides and round your answers to the nearest hundredth. So let's start with number 1 here. All right, so I know the angle that I'm supposed to use must be the 67-degree angle because that's the only one that was given. So this is my angle of reference, okay? The 3 different sides that we can label in our triangle are opposite, adjacent, and hypotenuse. Where is the hypotenuse located? To the right angle, right. So it's always directly across from the 90-degree angle should be our hypotenuse. Good. All right, what is going to be my opposite? Where would I look to find that? Is the 22 opposite of my angle? No. This would be the opposite side, right? Because it needs to be on the opposite side of the triangle from the angle. So that 22 must be the adjacent side. In case you forgot, adjacent means next to. So it's going to be the side next to your angle. All right? So it looks like we've got 2 missing sides we need to solve for. We need to solve for the opposite, and we need to solve for the hypotenuse. The thing is, we can only solve for one variable at a time. So let's say we want to solve for the opposite side first. So I'm going to look to find this side first. And the only side I currently know is the adjacent side. So I'm going to go back to my list. Which one am I going to use if I'm looking for opposite and I know the adjacent? Which one from my list? Which one has opposite and adjacent in it? Tangent. So I have to use tangent. I don't have a choice. Okay, so I'm going to have tangent of our angle, theta, which we know to be 67 degrees, is equal to opposite. That's the part I don't know. So you can plug in any variable. You can call it opposite, whatever you want to call it. It doesn't matter. But that's your unknown. Over the adjacent side, which we do know is 22. right? Okay, so I'm trying to solve for opposite, or whatever variable that you put in the top of your fraction. So how would I get rid of that 22? Multiply. So I'm going to multiply by 22. So over here, those are going to divide out. And because we did it on one side of the equation, we got to do it on the other as well. So this is what you would type in your calculator. Quick reminder though, remember your calculator must be in the correct mode. So everyone double check your calculators in the correct mode. You hit the button that says mode. And the third one down says radian and degree. You want to make sure degree is highlighted because our angle was given in degrees, right? It was 67 degrees. So highlight degrees, press enter to save it. Then you can go back to your home screen and type in the 22 times tangent of 67. All right, so when I multiply 22 times tangent of 67, what are we going to get for our opposite side?
51.8.
So they said to round to the nearest hundred, so it'd be 51 point what? 83. Very good. Okay. All right, so now we have found the opposite side. So I now know this one is 51.83. But I still need to find the hypotenuse, right? Now, technically, I could now use adjacent or opposite to help me find the hypotenuse. But I do want you guys to remember the answer that we just came up with is rounded, right? It's not an exact answer. So if you have the choice, if you've got something exact and something rounded, go with the one that's exact. It'll keep your answer being more exact, all right? So we're going to use adjacent to help us find hypotenuse. So adjacent and hypotenuse, what ratio is that? Sine, cosine, or tangent? Cosine. So we're going to have cosine of 67 degrees is equal to adjacent, which is 22, over the hypotenuse. All right. So this time the hypotenuse is in the bottom, so it might be more than just one simple step. But we do need to get rid of the fraction first. So how are we going to do that? Multiply by what? The hypotenuse, right? So you can either go ahead and say, okay, I'm going to multiply both sides by the hypotenuse. Or you could put cosine of 67 over 1 and cross multiply. Either way, you're multiplying both sides by the hypotenuse. However you want to think of that. So I'm going to have hypotenuse times cosine of 67 is equal to 1 times 22, which is just 22, right? But I'm trying to get hypotenuse by itself. So now what should we do?
Divide by 67.
Right, divide by cosine of 67. All right. So now this would be what we're putting in our calculator. 22 over cosine of 67. When we put that in, what are we going to get for the measurement of our hypotenuse? 56.30. Good. 56.30. Good. All right. Okay, let's do another one together. Let's look at number 2. So on number 2, here's the angle that was given to us, this 40-degree angle here. The side that was given, the 8.3, is that opposite, adjacent, or hypotenuse? Hypotenuse. Why is it the hypotenuse? Right, because it's across from the 90-degree angle. Okay? Okay, so that would mean that this side must be the adjacent side because it's right beside the 40, right? And this side must be the opposite because it's across from the 40. All right, so we're looking for adjacent and opposite. Let's say I'm looking for the opposite first. So I'm looking for opposite and I know hypotenuse. So if I go look back at my list, which ratio has opposite and hypotenuse? Sine. So I have to use sine. So I'm going to have sine of 40 degrees is equal to opposite over hypotenuse, which is 8.3. All right, so how am I going to solve for the opposite side? Right? So then those divide out. So then this is what we put in our calculator. 8.3 times sine of 40.
5.335.
Okay, so to the 100th, that would be 5.34. Good. Good job. Okay. Now I'm looking for the adjacent side, and I know the hypotenuse. So which ratio uses adjacent and hypotenuse? Cosine. Okay, so now we're going to use cosine of 40 degrees is equal to adjacent over the hypotenuse 8.3. Okay, well again, what am I going to do to solve? Multiply. So I multiply both sides by 8.3. These divide out. So this is what I put in my calculator. And what are we going to get for the measurement of the adjacent side?
6.36.
Good. Nice. Okay, so I want you guys to try to find the missing sides on numbers 3 and 4, and then we're going to share our answers here in just a bit. I'm going to give you a moment to find the missing sides on numbers 3 and 4. I'm passing back your reviews, guys. Remember, the only criteria was that you answer every problem and show all your work, because I gave you the answers, so I wasn't checking for accuracy. So if you have a check mark, you got full credit. looks like most of us have at least number 3 filled in. So let's share our answers for number 3. So on that one, our angle was 38 degrees. That 7.1 that they gave us, which side was that? Opposite. Good. Okay, so we were looking for hypotenuse and adjacent, right? All right, so if you were looking for the hypotenuse, which ratio did you use to find hypotenuse? Sine, cosine, or tangent? Sine. Okay, so we're going to have sine of 38 degrees is equal to opposite, which is 7.1, over hypotenuse. All right. Okay, if we need to solve for hypotenuse, what are we going to do first? How do we get rid of that fraction? Right. So over here, they will divide out. Over here, I'm multiplying by hypotenuse. Okay, and then what would I have to do? Divide. Good. So hypotenuse is equal to 7.1 over sine of 38, right? So what did you guys get for the length of your hypotenuse?
115.52.
What is it?
115.
Okay, 11 point, okay. 11.5, does it round to 5.3? Yeah? Okay. Okay. Now I'm looking for the adjacent side. Which ratio am I going to have to use to find the adjacent side? Tangent. Good. So I'm going to have tangent of 38 is equal to opposite, that 7.1, over the adjacent side. So what do I have to do first? Multiply by the adjacent. So I'm going to have adjacent times tangent of 38 is equal to 7.1. And then what am I going to have to do? Divide. Okay. So I'm going to have that the length of our adjacent side is what?
9.9.
Good. Okay. All right, number 4. On number 4, here was our given angle, right? 27. Okay. What's the 10? Adjacent. Very good. Okay, so let's say we want to find the opposite side first. So if I'm looking to find the opposite side and I know adjacent, I have to use what? Tangent. Okay, so I'm going to have tangent of 27 is equal to opposite over the adjacent 10. And how are we going to solve? Multiply by 10. Good. So the measure of our opposite side is going to end up being what do we get? Okay. And then we also needed to find the hypotenuse. So which trig ratio did we use to find the hypotenuse? Cosine. Okay, so I'm going to have cosine of 27 degrees is equal to adjacent over hypotenuse. So this time my variable is in the bottom. So what do I have to do? Right. So I have the hypotenuse times cosine of 27 is equal to 10. And then we're going to have to divide. So I divide both sides by that cosine of 27. All right, so the length of our hypotenuse is, nice. Okay. All right, so hopefully that kind of refreshes our memory on how we use trig to find missing sides. Now let's look at the next section where it says to find the missing angles and round those to the nearest hundred. So in this section, instead of looking for missing sides, I'm looking for missing angles. So the missing angle that we're looking for is the one that has the question mark on it. So that would be this one here. So what side is 34 to that angle? Opposite. And what about 55? Hypotenuse. Okay, so I know opposite and I know hypotenuse. Which trig ratio uses opposite and hypotenuse? So I must need to use sine here. Okay, so I'm going to have sine of theta, because it's an unknown, theta is just a variable like x, is equal to opposite, which was 34, over hypotenuse, which is 55. Okay, and then just like it said in the box up here, if you're wanting to get rid of sine, cosine, or tangent, you have to take the inverse of that function, all right? So if I take the inverse of sine, it makes sine go away, and all that's left over here is theta. But if I do it to one side of the equation, got to do it to the other, right? So I'm also going to take sine's inverse of the other side, which is 34 over 55. And then that is what you're going to type in your calculator. To do sine's inverse, you just press second before you press sine. All right, and rounded to the nearest hundredth, how many degrees is our theta? Very good. Oops. 0.18. Okay. All right, let's do number 6 together. On number 6, here's my missing angle. What is 29? What side is that? Opposite. And 38? Adjacent. Very good. So which trig ratio uses opposite and adjacent? Tangent. So I have to use tangent. I'm going to have tangent of theta is equal to opposite, 29, over adjacent, 38. Okay, and again, to get rid of sine, cosine, or tangent, we have to take its inverse, right? So I'm going to take tangent's inverse of 29 over 38. Okay? And what is that going to leave us? Good. Okay, I want you guys to do numbers 7 and 8, and then we're going to share our answers. Okay, so on number 7, if this was our given angle, what was 34? Opposite. And 42? Adjacent. So which trig ratio did you have to use? Tangent. Good. So you had tangent of theta was equal to that opposite 34 over adjacent 42. And how did we solve for theta? Take the inverse. Very good. So theta was equal to tangent's inverse of 34 over 42. So what'd you get for your theta? Good. Good job, guys. Okay, number 8, last one in this section. What side was the 56? Hypotenuse. And what side was the 52? Adjacent. So which trig ratio did you have to use this time? Cosine. So we had cosine of theta is equal to adjacent over hypotenuse. And again, to solve, what do we have to do? Take the inverse. So theta would be cosine's inverse of 52 over 56. Nice. So what did we end up with for theta? Good. Good job. Okay, the last section says solve each triangle by finding all of its missing measurements and rounded to the nearest hundredth. So if you'll flip it over on the back, we've got a couple pictures here to look at. So on number 9, we were given this angle of 23 degrees. And what is the 126? The hypotenuse. All right, so let's say I want to find the opposite side. If I want to find the opposite side, which trig ratio should we use? Good. So I'll have sine of 23 is equal to that missing opposite side over the hypotenuse 126. All right, and how am I going to solve for the opposite side? Perfect. So they'll divide out over here. I multiply on this side. And what do we end up getting for the length of our opposite side? Good. Okay. So we found opposite. What do we still need to find? Adjacent. So which trig ratio should we use for that? Cosine. So cosine of 23 equals adjacent over hypotenuse. Looks like we solved this one the same way, right? All we have to do is multiply by 126. So what's going to be the length of our adjacent side? Good. All right. And then the only thing missing now is this angle R, right? Well, now we do know the opposite side right here is 49.23. And I do know my adjacent side, 115.98. So now that I know all 3 sides, I could use any of those trig ratios. Sine, cosine, tangent, whichever one you want, okay? So let's say we chose to use sine. Okay, so I would have sine of theta is equal to opposite, which is found to be 49.23, right? Over the hypotenuse, which is the 126, right? And I could do it just like we did in the last section, where I take sine's inverse of 49.23 over 126. But does anybody notice anything else we maybe could have done instead? Right, so a triangle has to add up to 180. A right triangle specifically, we know that it already has 90 taken up. So that means that this missing angle and the one that we know is 23 have to add up to what?
20.
Just those two. 90, right. Those two angles are what we call complementary angles. So in addition to solving it this way, you also could have said the measure of angle R is 90 minus 23. because those two have to add up to 90. So it's going to end up being 67, right? You will also get approximately 67 if you did this as well. But remember, this has a rounded number in it, plus it gives you a decimal that you would need to round, right? So if it's a little bit off of 67, realize that's okay for that to happen, okay? All right. Okay, let's look at number 10. On number 10, here's my angle, 38. They should have marked this as a 90-degree angle, but they didn't. And what is the 11.9? The adjacent side. Okay. All right. So let's say we're looking for the opposite side. Which ratio would I have to use? Tangent. So I'm going to have tangent of 38 is equal to that opposite over adjacent, which is 11.9. So if I was going to solve this, what should I do? Good. So those divide out. 11.9 over here. So this is what I put in the calculator. What are we going to get for the measure of our opposite side? 9.30. Okay. All right, so now I just need to find the hypotenuse. Which trig ratio am I going to have to use for that? Cosine. So cosine of 38 is equal to adjacent, which we know is 11.9, over that hypotenuse. All right, so for this one, what do I have to do first? Multiply by the hypotenuse. All right, and then I'm going to have to divide by cosine. Very good. So what's going to be the length of our hypotenuse? Good job. Okay. All right, and then lastly, I could use sine, cosine, or tangent to find angle H, but I also could just subtract from 180 or 90, right? So 90 minus 38 is going to tell us angle H must be nice. Good job.